Okay, this is still 5.2 in the conic section of Math C30, and we're looking at parabolas. And we have done a couple of parabola tutorials already, and we're looking at now, what do you do when you have a parabola equation and you want to find all its features, but it's not in the nice form of the standard form with all the nice symbols already kind of half placed in the right spots to help you figure it out. It's just in its general form. So it's very similar to the circle. You have to complete a square in order to complete it into its proper form to be standard form. So we got to change this to standard form. So what we do first is we decide to ourselves, we look and try to find, is there just an x squared or is there a y squared? Or which one is there and which one isn't there? So the x squared is there, so that means that we're going to try to make everything equal to y. So I'm going to move the y over to this side. So that's going to make it y is equal to, so I'm moving it over there, okay? So that's going to keep all these the same sign here. 2x squared plus 20x plus 57. So then we have to work and think to ourselves, well, what do I want to do now when I'm doing this? I want to complete the square. But this does not have a nice simple square, or pardon me, 1 in front of there, in front of that squared x. So we have to take out a common factor there. So y is equal to 2 bracket x squared plus 10x plus 57. Okay, so now you can see that we can complete the square in the brackets here. So we go ahead and complete that square, take half of 10 and square it. But you have to be careful here, very careful. And you have to be careful about signs as well. So this becomes x squared plus 10x. Half of 10 is 5, 5 squared is 25, plus 57. Now if I look at this, I didn't actually add 25 into that equation, I added 50. 2 times 25. And be careful, I'm going to warn you, when this is negative, you'll have to remember that you're actually adding a negative. If this was a negative 2, this would have been a negative 50 that you would have been added. But in this case, we're adding 50. So if we add 50 inside here, because it's on the same side, we're working on the same right side of the equation here. We added 50 there, so we must subtract 50 here to keep the equation equal. So now what we do is we factor out this term, or this trinomial, into a binomial. So this is y is equal to 2x plus 5 all squared plus 7. And there we have a standard form of a parabola. And we would then begin to work with it as we did in our example in our second tutorial. We then try to analyze it to find the vertex and all the other characteristics. So this is being a vertical parabola because it's got a y equals, and it opens up because it's positive in front. So I'm going to draw it there. Its vertex, h is there, k is there. It's negative 5 and 7. Okay. Now we have to calculate the p-value in order to find out what the focus is over here and what the directrix is going to be here. We know what the axis of symmetry is going to be. If we look here, okay, that's a line, that's an x line, x equaling negative 5 all the way through there. So this is x equals negative 5. That's our axis of symmetry. Now we just have to find the focal point and the directrix. Let's just move that up to get it in the better form of view here. Okay, so we take that, we know that that 1 over 4p is in front, so we know that this 2, we solve for p. 2 is equal to 1 over 4p. So this is like 2 over 1. So if we cross multiply, we can solve p. 1 equals 8p. Divide everything out there, p is equal to 1/8. So the distance from the vertex to the focus is only 1/8. Now we're moving along vertically, so we have to change the y value because we're moving up and down. So this is going to be -5. And what's 7 plus 1/8? Well, that's 7 1/8. Sorry, that's difficult to read. And the directx is going to be, it's going to be again a line here that's horizontal. So it's going to be y equaling something. So we're changing the y point. What's 7 subtract 1/8? Well, that would be y is equal to 6 7/8. And that's our directx. And the latus rectum, the length of the latus rectum is just 4p. So take p and multiply by 4, so it'd just be 1/2 in that case. Okay, any question? Pardon me. Any other questions that we'll do in this area will be all kind of similar to these types of questions. There is other types of questions that they'll sometimes ask you. They'll give you some general characteristics about the vertex and the focus, or maybe the latus rectum, and they ask you to solve for the equation. And we'll do a quick example of one of those. So here's an example. Okay, they say, if p is 10 and it opens up, what is the equation? And the vertex is 1, 2. What is the equation and for the parabola? So if it's opening up, we know it's a vertical parabola, so y equals, and h and k. Okay, so we'll have 1 over 4p, so 1 over 4 times 10. 4 times 10 times, okay, and this will be x, and the x point will be -1 squared, and this one here would be +2. So then our form of the equation is just 1 over 40 x minus 1 squared plus 2. So there is our parabola. That one wasn't too difficult, but sometimes they'll give you some other ones where you have to think a little bit. Now, if they wanted it in general form, you'd have to expand everything out here. We don't have enough time on this tutorial to finish that up, so that'll be good enough. Now, other features of it, well, what is the axis of symmetry? Okay, it's a vertical parabola. Okay, and we know that it's going like this. We know that this is -1, or pardon me, +1 and 2. So it's going the axis of symmetry is going right through there. Okay, so our axis of symmetry is going to be a point where x equals 1, or a line, pardon me, not a point. So that's x equals 1. Our focus and our directx. Now our focus is going to be p away. So that's 10. Well, we add 10 to this. This would end up being 11, or pardon me, 1 and 12, because we have to add it to the y because we're moving up and down. And we subtract 10 from the y, and this would be y equals -8. So that would give us the rest of our features of that parabola. In the next section, we'll be looking at the ellipse in section 5.3.